Hello everyone. Today we'll present our project job recommendation system. With yeah, and before moving forward, I would like to introduce our team, which is Diginomads. I'm Chaitanya, and here we have Utkarsh with us, Sagar, and Rutik. Yeah. Next slide. Yeah. In today's presentation, we'll go through introduction, then discuss the purpose of our system, and we'll further dwell into the data mining methodology, following by a machine learning model we have used and alternative models we explored. Also, we'll discuss about how we tune our model, and finally, we'll discuss about the deployment and give a demo of the project. Next slide. Yeah. So moving to the introduction part, today we are diving into the world of job recommendation systems, a cornerstone of modern HR technology. These systems are not just a trend, they are a response to the growing complexity of the job market and the increasing need for efficient job matching. In developing our system, we have ventured beyond traditional job matching techniques, which were mostly based on the keyword matching. But in this project, we focused on personalized recommendations driven by data mining and machine learning. We utilize like Python for its versatility and rich library ecosystem, particularly in data analysis and machine learning. Key libraries like Pandas for data manipulation, scikit-learn for machine learning, and TensorFlow, depending on our model structure, were instrumental in building and refining our job recommendation system. Next slide. Yeah, so to understand the purpose of the system is our primary objective of our job recommendation system is to streamline the job search process. We aim to elevate the common challenges faced by job seekers, such as navigating through vast amount of job listings and finding the roles that match their unique skill sets and career aspirations. Our design, our system is designed keeping in mind the diverse needs of our target audience, which includes both job seekers and employers. For job seekers, the goal is to provide a user-friendly platform that delivers a personalized job suggestion based on their profiles, preferences, and past interactions. For employers, the system aims to present qualified candidates efficiently, reducing the time and resources spent on finding the right talent. The expected impact of our system is significant. For job seekers, it means reduced job search time, increased chances of finding satisfying employment, and access to opportunities they might not have discovered otherwise. For employers, it translates into a more streamlined hiring process, access to a broader pool of suitable candidates, and potentially higher retention rates, as they are more likely to hire candidates who are a good fit for their organization. For the next part of the presentation, I would like to hand it over to Sagar.
Hello everyone. I will be covering CRISP-DM methodology in brief detail. So let's start into it. First, I will talk about business understanding. So our goal was to develop a system that could accurately recommend job positions to the candidates based on the postings available. We identified key business objectives as enhancing the job seeking experience through personalized recommendations. We began by analyzing data set of LinkedIn job postings. This step involved getting familiar with the data, identifying the crucial features like job titles, which skills were required, and the experience levels, which are vital for matching candidates with the suitable jobs. And in the data preparation phase, we focused on cleaning and preparing our data for the modeling. This included combining textual data from job titles, descriptions, and transforming them into machine readable format using TF-IDF vectorization. Next slide, please. So we experimented with various models, starting with simpler one like logistic regression, moving to more complex models like random forest, and we eventually implemented neural networks. Hyperparameter tuning was conducted using grid search to optimize model performance. Model performance was rigorously evaluated using metrics such as accuracy, precision, recall, and the F1 score. These evaluations guided our iterative model refinement, ensuring the system's recommendations were both relevant as well as reliable. Though about deployment, though we haven't implemented, the final step would involve deploying the system into a web-based application, allowing real-time job recommendation for the users. The system would also be designed to adapt and improve continuously based on user feedback, aligning with the ongoing nature of the CRISP DM methodology. Thank you. That is all from my side. Now Utkarsh will take over.
Thank you, Chaitanya and Sagar. So moving next for model architecture, our primary model is a multi-layer feed-forward neural network chosen for its ability to capture the intricacies in job recommendation. The architecture includes hidden layers with neurons, each providing a balance between complexity and performance. Reason for selection, the neural network was selected for its superior capabilities to model complex and non-linear relationships inherent in job recommendation systems. Its flexibility allows us to easily scale the model and make adjustments based on evolving requirements, making it a robust choice for our system. Performance highlights, in our testing phase, the neural network achieved an accuracy of around 75%, which was significantly higher than the other models we explored. Um, for training process, to prevent overfitting, dropout layers were implemented, providing the necessary regulations to maintain the model's general generalizability. Regarding future scope, there is a potential to further enhance this model by exploring deep learning techniques, particularly as we gather more user data. Integrating the model with real-time user data will allow us to refine the recommendation continuously, adapting to changing user preferences and job market trends. Next slide, please. Yeah, so the other models that we explored are random forest, logistic regression, and gradient boosting machine. For random forest, we explored its robustness and effectiveness in classification tasks. It's known for handling large data sets well and providing insights into feature importance, which was invaluable during our initial explorations. For logistic regressions, as a baseline model, we tested logistic regression, and it's straightforward and interpretable, making it a good starting point to understand the linear relationships in our data. However, it is simplicity also meant limitations in handling the complexity of our data set. Regarding gradient boosting machines, we delve into gradient GVM, notably for their powerful predictive capabilities, particularly implementations like XGBoost, Light GBM, and CatBoost, uh, that are renowned for their performance in various machine learning competitions and real-world applications. Uh, One of the key reasons we considered GBM was its proficiency in handling tabular data, which is a significant component of our project. GBMs are excellent at capturing complex patterns through decision tree ensemble, making them a stronger candidate for our recommendation system. However, despite their strengths, we observed some challenges. GBMs can be computationally intensive, requiring careful tuning and resource management. Moreover, the model interpretability is relatively lower compared to simpler models, which was a crucial aspect for us to ensure transparency in job recommendations. In conclusion, while gradient boosting machines showed great promise due to their accuracy and handling of complex data sets, we ultimately opted for a neural network implementations. The deciding factor were the neural network's flexibility, scalability, and the ability to integrate seamlessly with our existing web-based platform. Next slide, please. So regarding model tuning, for parameter optimization, we employed grid search CV, a systematic approach to tuning hyperparameters. This helped us identifying the optimal setting for our random forest model, such as the number of trees and depth of trees, among others. Finding the right combination of these parameters was crucial for enhancing the model's accuracy and response time. For feature selection, we conducted an in-depth analysis of feature importance, which led to refining the input features. This step was essential to improve model efficiency and focus on the most impactful data. By selecting the most relevant features, we were able to reduce complexity and improve the model's interpretability. Regarding Regarding model complexity, an important aspect of our tuning was to find the right balance in model complexity. We aimed to avoid overfitting while maintaining a robust predictive power. And to achieve this, we applied regularization techniques, which helped in generalizing the model better to new unseen data. Cross-validation, we use K-fold cross-validation to ensure the stability and reliability of our model. This technique helped us assess how the model would perform across different subset of the data. It was a key step in confirming that our model tuning was effective and that the model would perform consistently in real-world scenarios. And for evaluation metrics, our focus was not just on accuracy, but also on a precision recall and the F1 score. This metrics provided a more holistic view of the model's performance, especially in handling imbalanced classes. We also use the ROC-AUC curve as the comprehensive measure to assess the model's ability to distinguish between classes, which is a crucial in recommendation system. Moving next, I would like to hand it over to Ritik.
Okay, now we will move ahead with the deployment part. Our Flask application serves as the backbone for deploying our machine learning model. It's configured to handle user requests and provide job recommendations in real time. We have developed a RESTful API within the Flask app, enabling seamless communication between the user interface and the machine learning model. When users upload their resume on our UI, it is processed in backend by our Flask app. The app efficiently loads the pre-trained job recommendation model and uses it to generate relevant job suggestions based on the user's input. Okay, now we'll move ahead to the demo part. Okay, so in this collab, basically what we are initially doing is we are handling the data set. First of all, we'll install all the necessary libraries. Then we will handle the data set. Our project utilizes a comprehensive dataset comprising various aspects of job postings, including job titles, descriptions, required skills, experience levels, and industries. This rich dataset has been sourced from Kaggle, provides a nuanced view of job market, enabling our model to make well-informed recommendations. The diversity and volume of the data were instrumental in training our models to understand and predict job seeker preferences accurately. Here we are handling the data pre-processing part and data cleaning as well. Okay. Now next we will move on towards the data mining methodology. We are performing CRISP DM. Like our project is mainly focused on CRISP DM methodology. So here you can see that we have employed a range of techniques in our job recommendation system. Which not only includes data processing methods like normalization, but other methods such as feature engineering using TF-IDF for text data and encoding categorical variables. Firstly, this EDA part consists of various visualizations, as you can see here. Okay, so in feature extraction and processing, basically, we are using TF-IDF for text data and encoding categorical variables. We explored various machine learning models such as random forest, gradient boosting machines, and neural networks, each offering unique strengths. Advanced techniques like NLP for processing job titles, descriptions were crucial for extracting meaningful insights from textual data. Okay. Okay, now moving towards the next part, which is very important to us, which is comparing the performance metrics. We have used TensorBoard. To visualize the performance metrics. But before moving there, we'll talk about other parameters for performance metrics. In comparing performance metrics across models, we have mainly focused on accuracy, precision, recall, and F1 score. Our neural network implementation emerged as the top performer with highest accuracy and F1 score, indicating its effectiveness in both correctly identifying relevant jobs and maintaining a balance between precision and recall. While there are other methods like random forest and GBM, which showed good results, but they fell short in comparison to our main primary model. Moving on to give you more visualization of comparison of different metrics, I'll show you the TensorBoard implementation. So this is how the TensorBoard looks like after reading all the correct values. Here you can visualize. TensorBoard provides us with interactive visualizations, which can be used to compare models. There are different parameters which you can use for visualization. Okay, moving ahead. Okay, so the main out of all the models, after thorough testing and evaluation, the neural network model stood out due to its adaptability and ability to handle the complexity of our dataset. Its layered architecture and non-linear processing capabilities made it exceptionally suited for intricate tasks of job recommendations. The decision was also influenced by model's integration potential with our web-based platform, allowing for seamless real-time recommendations. Okay. So further on, we have also to deploy our neural network model in production environment, we utilize Python's pickle library for serialization. Pickle enabled us to save the trained model as a binary file, which can be easily loaded and used for predictions in our Flask-based web application. This process significantly simplified the deployment process, allowing our recommendation system to operate efficiently and reliably in real-world setting. Now let's move towards the UI deployment. Okay, the app is starting up. Now here we will upload some resume samples just to demonstrate like how job is recommended. Okay, so let's take this for a test. Okay, so as you can see that it detects all the skill sets from resume and recommends job. Like for that resume, it recommended human resource manager to be the best job role to apply for. Let's try another example. Okay, so now for the second example, our job recommendation system is recommending SEO specialist because it has seen that the resume contains skill set which are most suitable for SEO specialist role. Yeah, so that was it for the demo. Okay, that was it from our side. Thank you very much for kindly listening to us. Let us know if you have any concerns or any questions related to project. We'll be more than happy to answer those in the comment section below. And yeah, thank you very much.